Hey everyone, so this is the last video for section 6.1. And now what we are working on is still operations with radicals, but now we're going to talk about adding and subtracting radicals. In the last video, last week, we talked about multiplying and dividing radicals. We obviously need to talk about adding and subtracting, and so we're going to go over some important things to remember and some important things to know when adding and subtracting radicals. So a couple notes to start here. Adding and subtracting radicals is similar to the idea of combining like terms. We know how to combine like terms, so just kind of always come back to that because it's something we know how to do, where you can only add terms that have the same variable, right? We know that. We can only add terms that have the same variable raised to the same exponent. Like that's not new. Then add or subtract the coefficients, the number in the front. Right, so that's a skill we've learned how to do before. Here's an example. Combine like terms. Remember, we look for variables that have terms that have the same variable and the same exponent. So if I see x squared plus 2x squared, I know I can combine them, combine like terms, because they have the same variable with the same exponent. So x squared plus 2x squared gives me 3x squared. Some other like terms, look, 2x minus 4x. 2 minus 4, that's going to give me negative 2x. And then that minus 5 is by itself. So it's the same idea, okay? So in order to add or subtract radicals now, you must have the same index. Remember, index is that number, that tiny number in the radical, and the same radicand, the number underneath the radical symbol. So this radicand is that number. Then we add or subtract the coefficients. So same exact process. Check to make sure some things are the same, and then we combine the coefficients. Remember, the coefficients are those numbers in the front, like the 2 and that negative 4 were coefficients. The 1x, the 1 there, and the 2 were coefficients. Okay, so notice here in this example, we need numbers to have the same index. Let me get a different color here. We need them to have the same index, same number right there, and the same number underneath the radicand. So if we look through, if I will just look at these first two terms, 2 square root of 3 plus 3 square root of 3, they've got the same number right here, and they've got the same number underneath the radicand. So they have the same index, so there's nothing here, which means it's a square root, and they both have the same number underneath the radicand, so underneath the radical, so we can combine them. And we combine them by adding or subtracting the coefficients, the numbers in the front. So 2 plus 3, we know that gives me 5, and we keep the square root 3. Okay, let's look for the next like terms. Cubed root of 5 and 3 cubed root of 5. So again, we've got the same index. They both are cube root, and they both have the same radicand, the number underneath. So I've got 1 cube root of 5 plus 3 cube root of 5. That gives me 4 cube root of 5. And then minus 2 square root 6 doesn't have anything to combine with, so we can leave it just like that. Okay. Notice some things to remember here. Square root of 24 plus the cube root of 24 cannot be combined because they've got different indexes, right? This number right here matters. So if we don't see anything, remember that's a 2. It's a square root. And the square root of 3 plus the square root of 6 can't be added together because they have the different radicands. So they're both square roots. They just have different numbers underneath the radical, so I can't combine them. What's important to note is that sometimes in order to add or subtract radicands, we must simplify the radical as much as possible first. Okay, so let's check out these examples. So A here, I'm going to erase this so I have a little bit more room. Okay. Add or subtract the expressions below. So when I look at this, 2 square root of 2 plus 4 square root of 8, I've got the same index, but I don't have the same radicand. But can I get them to be the same radicand by simplifying? So 2 square root of 2 doesn't break down at all. But if I look at that 4 square root of 8, and I'm going to pull it out over there. We know we can use a factor tree to break down that 8. So then I could do 4 times 2, right? With the 4 in the front, and then I've got 4 times square root of 4 is 2, and then it becomes 8 square root of 2. So would you look at that, guys? I can say 4 square root of 8 is the same thing as plus 8 square root of 2. Now I've got the same index and the same radicand, so I can combine the coefficients. 2 plus 8 gives me 10 square root of 2. And I don't need that square there. And that's my answer. If I look at B, so I've got square root of 48 minus square root of 12. Indexes are the same. Radicands are different, but can I simplify to get the same? So let's break down 48. 48 I can break down to square root of 16 and the square root of 3. Square root of 16 I know is 4. Root 3 I can't do anything with. Let's look at 12. Goes to 4 and 3. Square root of 4 gives me 2. Square root of 3 I can't do anything with. I'm subtracting. Notice they've got the same indexes, same radicands. 4 minus 2 gives me 2, and we keep that radicand the same. And then let's check out C here. Square root of 5 I can't do anything with, right? That's nothing. I can't break down anymore. 24, let's break down into 4 and 6. So then square root of 4 gives me 2. Square root of 6 doesn't break down anymore. I'm going to bring down that square root of 5. Plus 2 root 6, let's break down minus square root of 20 gives me 4 and 5. Square root of 4 gives me 2. Square root of 5 stays the same. So out of what's left, what can we combine? Notice I can combine the square root 5 and the 2 square root 5. So I've got 1 minus 2 square root 5. 1 minus 2 gives me a negative 1 square root 5 plus 2 root 6 doesn't simplify anymore. Okay? So just be careful when simplifying these radicals when you add and subtract them. Really, really remember these bulleted points and the notes here, guys. Okay, this is going to be what's the most helpful for you. Is we need to make sure they've got the same index and the same radicand, and we have to add and subtract the coefficients. That's really what's most important. So if it takes using different colors to underline them, if it takes highlighting them, the coefficients is what we're after. So like here, I was just doing 2 plus 8. That's how I got the 10. Notice the square root 2 stays the same. 4 minus 2 is 2. Square root of 3 stays the same. 1 minus 2 gives me negative 1. Square root 5 stays the same. And 2 square root 6 doesn't have anything to combine with, so we leave it alone. Okay? Short notes, but a big concept to practice. So that's what we'll be doing this week. Great job, guys.